Hi, welcome back to our second video for 2.3, horizontal and vertical translations of functions. We're now looking at the second example, describing transformations. So it says for each function g of x, so I've kind of spaced them out. The first one's on this page, B and C are on the next page. So all of these tell us g of x, okay, it's some function. So describe the transformation from a base function of f of x. So g of x is taking one of these base functions, okay, we're not sure which one it is, and then it's doing some things to it, okay? So we can see, because this one is squared, that it actually is working with this base function, and it's applying some transformations to it. So we want to describe those functions using, we want to describe the transformations using function notation and then using words. Once we've done that, we're just gonna sketch the graph and then state the domain and range for it. Okay, so before we begin, we're just gonna recap some of the things that we learned from the Desmos investigation. So in the investigation, we learned that a function g of x, if it's equal to another function plus c, then that means all we need to do is take the base function and add c to it. And the effect of that will be that it's going to shift vertically, either up or down. So if c is greater than 0, it shifts up. Okay, exactly c units. If c is negative, so if c is less than 0, then it shifts down c units. Usually write these little word units in here at the end. Okay. So the other transformation that can happen is if we take the base function and then we manipulate x before it gets processed. So we subtract a parameter d from it. So if d is greater than 0, this shifts right d units. I'm just using the arrow to kind of save a little bit of space. If d is less than 0, it shifts left d units. Okay, so when this says if d is less than 0, that means d would have to be like negative 1. Remember, if you plug negative 1 into here, if you put negative 1 in, you're going to have x minus negative 1, and this is going to show up as x plus 1. Okay, so remember this d, it's always the opposite of how it's going to look inside of the brackets. So those are our two rules. So we're going to see if we can pick up on what's happening in here. So g of x is some function, and we can see plus 5 has been added on the inside. That'll correspond with d. And the plus 1 on the outside, that's going to correspond with c. So we could see there's two transformations that have taken place here. Okay, so let's first identify the base function. So we know that f of x equal to x squared is the base function. Let's say base function. Okay, so in order to get g of x, we're taking f of x and we're doing some stuff to it. So what are we doing to it? Well, it looks like we're adding 1 on the outside. So I'm going to kind of start to create this. I'm going to say g of x is equal to f of x plus 1. Okay, so what that means is if f of x is x squared, right now I just have x squared plus 1 for g of x. Notice that looks a lot like this. It's just missing one thing, and it's inside with x. It's missing that d value that needs to be in there. So let's go ahead and do that. We'll take g of x, and I'm now going to say it's equal to f of x plus 5 plus 1. Okay, so now I've described the transformations and function notation. Okay. So this just says g of x is going to be equal to f of x plus 5 plus 1. Okay. One way to also verify this is to actually do this to the base function. What do you mean do this to the base function? Well, if you remember when we said f of 0 and we wanted to evaluate that, we would just go to our f of x and we would take that 0 and we would plug it in, right? And we would evaluate it. We would say it's 0 squared. Well, what if I say do f of x plus 5? What does that mean? Well, that means take whatever is inside the bracket and plug it in for x. Well, that would be x plus 5 squared. Okay. Well, what if I say take f of x plus 5 and add 1 at the end? Well, that's easy. That'll just be x plus 5 squared plus 1. So notice this is what we have for g of x. So I can easily see that g of x is just equal to this. Okay? Because this is equal to x plus 5 squared plus 1. So that's what I wrote in here. So this is a way of describing the transformations using function notation. It's basically saying a new function g of x is equal to some function f with a horizontal translation of 5 and a vertical translation of 1. Okay. When we have this in this form, it's real easy to identify D and C. Okay, remember D is always the opposite value of this, so D is going to be -5, and C is always this number here, it's just going to be 1. So that tells me what's happening with the transformation. So to express this in words, I would say g of x is f of x translated, because d is -5, that means we're going to go to the left 5 units. It's going to go to the left 5 units and 1 unit up. Okay, so these are the transformations in words. You can use translation, you can use the word translated, or you can use the word shift. Okay, both are acceptable. Okay, so this is the transformation in function notation. This is the transformation in words. Let's go ahead and finally try to get our graph. So it says, to graph g of x, it says transform the graph of f of x. So that means I should draw f of x equal to x squared first. That's going to be my parabola. And then we'll transform that. Let's do f of x, and we'll do this one in black. So f of x equal to x squared. We're going to write out our table of values. Now you're going to want to memorize these. This is my base function, and I call these like P points. So to get a good parabola, we like to use a couple negative values and a couple positive ones. So plugging these into the function for x, that's going to help me get the y values. So plug in -2 squared is 4. You guys get the idea. I'm just going to go ahead and fill out the rest of this. Sub in 1, and I would -1, and I would have -1 squared to get 1. Plug in 0, I get 0. Plug in 1, I get 1. Plug in 2, I get 4. So there's these base points, and you guys kind of remember the step pattern. You go over 1, up 1, and then you go over 1, and then up 3, right? To get those. So same with the left side. That makes up a really good base function. I could actually get one more, and I could get 3, 9. That would be up here, and -3, 9. So this is f of x. Get my arrows on there, label it as f of x, the base graph. So now we want to apply the transformations. So I'm just going to kind of cheat a little bit. I'm going to go over this with my pen in one full line. And maybe you guys might guess what I'm going to do with this, but because we're just doing shifts, I can actually, on the iPad, I can copy this over. Okay, I can copy it and I can do the shifts that I need to. Okay, it's kind of convenient. And the only reason I'm doing this is because this actually shows what a translation is, because it's not a change in shape, it's only a change in position. So our first move, which we said in words, we said it translated left 5 units. Well, let's move this over to the left 5 units. And I'm going to change the color to green. So there's my graph shifted over 5 units. Okay. The points, notice there's always exactly 5 units in between. So this one goes to there, this one goes to there, and that one goes to there. They're all a distance of 5. So now we also need to do a vertical shift up 1 unit. So we'll go ahead and we'll do that next. So we'll go like this. I'm going to hit copy. Then I'm going to hit paste. I'm going to change this to red. And then we'll move this. So this is the green graph, but it's supposed to shift up 1 unit. So I'm going to move it up exactly 1. So this would be g of x. So all the green points had to move up 1. Now, notice that's 2 transformations. That's not really fun, having to draw the graphs one step at a time. What we're going to do is we're going to do point mapping. We're going to map those points into new ones. And I'm going to apply both transformations at the same time. So I'm going to do this for my mapping symbol. This is going to give me g of x, which is basically f of x minus 5 plus 1. Sorry, it's plus 5 minus 1. So that means my x values, they have to go to the left 5. So we're going to write x minus 5. That way they shift to the left 5 units. And then the y values, those have to go up 1 because it shifts up 1 unit. So notice the green graph isn't affected by the vertical translation. Like when we shift over to the left 5 and then go up 1, well, that doesn't change the horizontal translation at all. So what I'm trying to say is we could have actually went up first and then move over to the left, and you get the same result, same final result. So those translations are independent from each other, and doing one does not really affect the other. Okay. All right, so let's go ahead. Let's do our point mapping. We're going to take our value of x, we're going to plug it into here, and we're going to calculate it. So negative 2 minus 5, that's negative 7. Plug in negative 1, negative 1 minus 5, negative 6. Plug in 0. You guys get the idea. You can tell they're actually just going down by 1. Actually, I say they're going up by 1 because they're negative. Plug in 2, 2 minus 5, negative 3. So these are all my new x values. Now I'm going to go ahead and I'm going to take these y values and I'm going to plug those in for y, and I'll do my calculations for that. So 4 plus 1, that's 5. And then we have 1 plus 1, that's 2. 0 plus 1, 1. 1 plus 1, 2. 4 plus 1, 5. So I now have these new ordered pairs. So the point negative 2, 4, I can see becomes negative 7, 5. Okay, negative 7, 5, that's going to be, we'll do this in pink, negative 7, 5, that's right here. Okay, and that's on my red graph. I have another point, negative 6, 2. Well, negative 6, 2, that's right here. Negative 5, 1. That's easy, that's right there. And then negative 4, 2. That's right here. And negative 3, 5. that's going to be right here. Okay, so this point mapping is really great, and you can see I easily just took my base ordered pairs and I applied both transformations in one shot to get all the new points for the transform function. Okay, we're supposed to state the domain and range for both of them. So for the base graph, just x squared, the domain is x is an element of R. For the range, y, we have y is an element of R. Y is greater than or equal to 0, right? That's our black graph right here. Okay, for the transformed ones, for g of x, I'll do this one in red. The domain, also x is an element of R. There's no restrictions for quadratics, so it's always x is an element of R. Notice though our range, our y values start at 1 and then they go up. So we're going to have everything greater than or equal to 1. Not 0, 1. Okay, so that is our first example. These key points, just to remind you again, you're going to want to hang on to these. Okay, so I would make a nice clean list. These are always the points that we use for y equals x squared. So anytime you do any type of quadratic with transformations in it, you're always going to resort to these base points, and then you'll be doing the transformations to get new ones. So keep these someplace handy for you to use.